Welcome to Chemistry Simplified. Our topic for today is mole and Avogadro's number. So we're going to explore the relationship that exists between moles and Avogadro's number. Particles such as atoms, molecules, and ions are measured in mole. Mole is a very important concept in chemistry, especially in stoichiometry, because it helps us to establish relationship between different parts of the substance that we are studying, such as atoms, molecules, and ions, even grams. For example, 1 mole is equal to Avogadro's number, which is 6.022 times 10 to the 23rd. So a mole is like a dozen. You can say a dozen people, a dozen cat, a dozen chairs, whatever you want. So that's how you should look at the mole concept. So we can say 1 mole of sulfur is equal to Avogadro's number atoms of sulfur, which is 6.022 times 10 to the 23rd. Moreover, we could also say 1 mole of water is equal to 6.022 times 10 to the 23rd molecules of water, because water is a molecule. Furthermore, we can also say 1 mole of sodium chloride is equal to 6.022 times 10 to the 23rd formula units of sodium chloride. Why? Because sodium chloride is made of ions. Remember, sodium chloride is held together by an ionic bond. Let's now look at the step to convert moles to molecules. So let's say if we were given moles, we would multiply by Avogadro's number in order to get molecules. So let's look at an example. How many molecules are present in 1.75 moles of water? So we need molecules of water. So we start with what was given, 1.75 moles of water times, since mole is on the top, we also need moles on the bottom. Why? So we can cancel it out. And we know that 1 mole of water is equal to 6.02 times 10 to the 23rd molecules of water. So 1 mole goes on the bottom, and Avogadro's number should go on the top. All we have to do is to cross out the moles, and the answer is 1.05 times 10 to the 24th molecules of water. Now let's look at the opposite. Let's say we want to convert molecules to moles. So let's say we're given molecules and we want to get moles. So this time we would divide by Avogadro's number in order to get moles. Let's look at an example. How many moles of water are present in 1.04 times 10 to the 24th molecules of water? So we need moles of water. So we start with what was given, 1.04 times 10 to the 24th molecules of water. If molecules of water is on the top, we also need molecules of water on the bottom. Right? What's the relationship between molecules and moles? Avogadro's number. 1 mole of water is equal to 6.02 times 10 to the 23rd molecules of water. So this time, 6.02 times 10 to the 23rd will go on the denominator, and the 1 mole will go on the top. We cross out molecules, and the answer is 1.73 moles of water.